morning, everyone. I'd like to thank again PGSS SKE for inviting me to do this talk on digitizing your data. So one of the things as a researcher, postgraduate student, as well as a lecturer, we want to get data from journal paper to benchmark or to compare with our model. So that is why it's important to get the data. Right? So how do we get the data from journal paper from outside? So I'm going to show you a software that I just found recently. Before that, I found many digitizing software that you can use to do that. Some of it you have to pay yourself, but I just found this one, which is quite good. They can do the extraction for you automatically. You can do it manually, and it is free. All right. So what is actually a digitizing software? It converts an image file showing a graph of a map into numbers. So that is it. So for the type of graph that you normally can digitize is the normal X and Y scatter plot, that kind of graph. If you want a complicated graph, something like in communication like that, it's not really feasible. You cannot do that. So it's actually normal graph. So what it means here is that once you get the data, you digitize it, you get X and Y, you can export it as a CSV file, which is in spreadsheet, Excel file. You can open in Excel, all right, and you can plot it. But usually for my PhD student, they will normally plot it in MATLAB. So you can take the CSV file, open MATLAB, import the file in, and you can plot. So I will show you step by step how to do that from the PDF. You're going to get the X and Y. We create a CSV file. The CSV file you can open in Excel, or if you want enhanced plot, you can open in MATLAB. So why would you need this tool? You are an engineer with some graph, but you really need the numbers represented in those graphs so you can do further analysis. Okay. So what else? You are a graduate student gathering historical data from charts for your thesis. You need to get experiment data. So this is normally the case that we face. We want to get data from other sources. So let's say that this is how I do it. This is actually a paper from University of Cambridge. This is all my colleague at that time. So let's look at this graph. First of all, I would say that you want to identify a figure from the paper. And I saw the question just now, said how do we actually get this graph into the software? Well, you have to use a print screen. A normal print screen will do. In a function in your computer laptop, you just press a print screen and you get the graph. Okay, once you get this print screen, the next thing you do, you get something clean like this. Print screen, you get the graph. You can see, okay, this is what the graph that I meant with scatter plot. We have a lot of data. We got 4, 1, 2, 3, 4, 5. We got 5 legend here, 1, 2, 3, 4, 5 legend. And we got multiple VDS. These are the graph here. So if you were to do it manually, you can. You just have to click many times using your mouse. You click, 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 and you can do it until the end. Or you can use this auto function that I will show you later on. You just mark it or shadow it, and you click enter, and you'll get it. Obviously, you'll find some of the plots will not be perfectly matched with this scatter plot, but you can adjust them. You can just bring your mouse there. You can adjust it, put it below or after to fit it accurately. First of all, I'll just explain to you how to do it using this PowerPoint. And after this is done, we'll do it together. I'll just open the software and show it step by step. And I can assure you, if you're as good, you can just finish this less than 5 minutes. It's as simple as that, because most students or most people that do not know how to use this digitizing, they say it's extremely difficult. Even last time when I did not know about this software, what I did was I take a ruler, I print it out myself. I take a ruler, I put the centimeter. I say, okay, this first dot, 2 cm, 3 cm, 4 cm. I do it manually and I put in Excel. That was like perhaps like 15 or 20 years ago. But now you don't have to do that. By using simple software as this, you can get your graph easily. Scroll down here. So I have a question just now. How do we get this graph? You want to get this graph, right? Just press print screen. You look at my software, right? Can you see my software? Can you see this? I'm dragging it right now. And I already got the graph. Open. All right. Open image from file. I hope you can see it right now. Open image from clipboard. This is the file just now. Okay. You get the file. Okay. fit image to pane so you can see everything clearly. All right, I can see everything clearly. This is the graph I got. Okay, I'm happy with it. All right, next, first thing you do, the x-axis. Okay, x-axis, you click on here. Then there's a plus sign here. The plus sign, I'm moving it here. You can see it. I'm clicking here, -10. You can see there's an arrow right now, right? So say, where's your maximum value for your x? Where's your maximum value? Maximum value is over here. Just click it, you're done. And then what's the minimum and maximum? -10 to 10. -10 to 10, and you're done. You click OK. You're already done. X-axis, you can see over on your left side corner, minimum value -10 and 10. How about for your y-axis? For your y-axis, you can start here, -13 to -5. All right, -13 to 5. Then I have this question before. Some student ask, sir, I have a question. If I start from -12 here to -6 here, can it still work or not? Can it still recognize -13? All right, let's start from here. Let's say let's do some example. Let's start from -12 here. Obviously, I should start from there, but I'll start from here. See, can it still work or not? Maybe I'll stop to -6 lah. I'll stop to -6. All right, just 1e -12, 1e -6, and I choose log. Right, 1e -12, 1e 6. Okay, so how do I know it works or not? All right, so now already done it. Can you see the coordinates? Can you see the coordinates on your, this is very small, on your bottom right corner? Can you see the coordinates here or not? Yeah, this is the bottom right corner, down here, is over down here. If I move it to the end here, what it written here is about -10 to 1e -30. So it's still recognized. Although just now, for my y-axis, I only start from -12 to 6. When I put over here, in fact, when I put outside this plot here, you still recognize. You see, all the values that you put here, even outside the plots, you still recognize as a data point. So it means that the software is very flexible. So sometimes the graph, I've seen some journal paper, they don't have this value here. They don't have this value here. They start something in between. You can use that. Okay, we're done right now. So the feature right now, do you want to see automatic or manual? Asking, do you want to see automatic or manual?
Manual. Try manual.
You want to see manual? Okay. All right. So to do manual is easy. All right. We're done already. X and Y, we're done already. We do manual first. You click manual. Okay. So this is how you click. There. Can you see? So you say that, sir, how accurate it is? It is how you click lah. Yeah, suddenly, if you click like that, of course, obviously, it's not going to be accurate anymore lah. So it's how meticulous or how detailed are you? So, oh, they did a mistake here. What do I do? You just delete it. Go ahead, delete. Yeah, you delete the data point here. As easy as that. Okay, so I'm just clicking here. Okay, let me make a mistake for you lah. So I'm clicking here suddenly, and then this part I suddenly put on top here lah. Let's say I do it like that. Then I forgot about it. You know, maybe I forgot about it. I did everything done here. Oh, done. Click first. Click. Very simple. Just clicking here only. Data done. Clicking up and down. Okay, I done that. Okay, I click everything already. Then I say, okay, click to end series. Okay, so I already got my data point. But then after that, I found, I did a mistake just now. Oh, what can I do? I did a mistake here. Oh, should I do it again? No, just press here, select and move a node. Just press this sign here. You see? Move it back. That's easy. See, so easy. So since, let's see, like if you make a mistake earlier on, you say that, oh, I did a mistake. I should have. I just want to adjust this part here to go to here. You can adjust. You adjust manually. Adjust the part here, go down here. Right. Very flexible. All right. You done that. Now the next thing you do, you go to the next step, the graph data. Or done. See, you already got the graph. As easy as that. I just double click. You already got the graph here. If you want to use the graph here, let's say like if you're fast, you want to use the graph, maybe not for journal paper maybe just to reporting to your supervisor, I got this graph, I don't want to use MATLAB. Yeah, you can use here. you can edit the title, y-axis. What is the axis name here? Source drain current. Source drain current. Okay, just go to here and just label it source drain. See, as easy as that. And then what is your graph data here? Gate voltage. Okay, gate voltage. Gate voltage. Okay, and how about you can do many things with legend. You want thin. This is the legend here, the series here. Sometimes you don't like the name called series here, right? So what is actually is called VDS 1000 MV. Can we change that? Yeah. VDS. And then you say it doesn't change that, you have to click back here. Go back here. Yeah, already changed here. So which means that sometimes it doesn't update. What you do is that instead of clicking all this part here, it doesn't update. You just go back to the data point, and then you go back to the graph. Then it's already updated for you. And the series, what color do you want? If you want to have it, let's see what color. I choose pink just now, and you choose pink here. Change color and choose any pink color that you like. You already got it there, and you already done it. And you say, I'm happy with it. I want to export it as an image, and this export. Okay, export it as a PNG file. We just type it example1 ex1, and then we open the figure. There, you already got a figure. As easy as that lah. So this is not using MATLAB. This is using the software itself. But if you want to use MATLAB, how do you do it? Okay, all right. Let's see an example. How do you use MATLAB? So if you want to plot it in MATLAB, what next thing you do is that you grab data, you say export as a data file. Okay, export it as a data file. All right, DIGITIZE example. Obviously, you can name it as any name you want. So the reason is that I name it as experiment data, any name lah, data.csv. It has to be CSV file lah. Normally when you save it, it's a CSV file. So I already save it. I don't want to overwrite my file. Maybe I put 456 now. Okay, then we go back to PGSS over here. Then we open our CSV file. All right, there you go, the X1. This is the important thing. Anything that you do, you want to get this X and Y. Because by getting this X and Y, then you can plot your graph. Okay, I'm getting the X and Y. Next thing you do, you open your MATLAB. Okay, let's open my MATLAB. And then I open main one. Yeah, I just press F5. F5. There you go, that's the plot. You see, clear all, close all CLC is just a initialization means that clear all this, remove all this data. So the important thing is these 3 lines here only. You get your CSV file, you read the table. So it becomes a table, and then you change it to array, and then you plot the first. Obviously, you have to know some basic of MATLAB. This is what the column means, which means that take the first column. Then what is the column mean? The column means that all the, which means that take the first column, and then the column which means that all the rows. What row? Is it until 73 or what? You say take until finish the data. So until row 73 lah. That's what I mean. And then after that, plot take the column number 2. Take column number 1 versus column number 2. Look at the sign here. This A here. Take column number 1, plot column number 2. Then you run it, press F5. And you get the graph here. And then we go just run a more complicated one, the main one. Right? This is a much more complicated curve. So when I run it, look at this curve here. And this one, I run 2 codes. I got main 1 and main 2. What's the difference between main 1 and main 2? The difference between main 1 and main 2 is that the main 2 has more. Let me see. Yeah, main 1 and main 2. What's the difference? Now opening bigger and bigger. You see that main 2 has more dots, more dots, and main 1 has less dot. All right. So how do you get high quality curve from here? All right. So no common mistake. that student normally do, common mistake, what they do? They just say file, save as. Okay, and just they do it like this, file, save as, and then okay lah. Maybe I want to get a better one. You can choose PDF or what lah. Normally, if you choose JPEG lah, okay, let's say I'm doing it right here with you I'm doing here figure 1.jpg. Save it. Okay, I'm figure 1.jpg. Save it. All right. I have to open a Word file right now, and I have to share with you. Okay, let me share my Word file with you first, so at least you can see what I'm doing. So you're writing a paper. Normally, paper is in Word file, right? I'm gonna open new one. Okay, open new one. Everybody can see my. Okay, then you obviously that's how you do it lah. Insert this figure here, and you get your. Okay, let's look at my figure just now. Okay, this is my figure that I get, right? Okay. So far from outside, from here it looks clear From here it looks okay. Then normally when you submit to journal paper, they say that okay, you have to create a PDF, right? Okay, I'm going to create a PDF. Say I print as a PDF. Let me select my PDF, Adobe PDF. Obviously PDF here, I select high quality print. I select high quality, everything high quality, A4 here, size here. I'm going to print, press OK. I'm going to print here. It's already high quality. It's printing right now. It's printing right now. I'll go to my desktop. I put document 1. I say okay. All right, it's printing right now. All right, I got the PDF right now. Okay, I got my PDF right now. Then you say it's high quality, right? Let's see it's a high quality or not. So let's start zooming in. Zoom. See, it's not high quality at all. Let's get back to MATLAB and we solve the problem. Okay, let me minimize this and getting back to MATLAB. All right, in MATLAB just now, okay, this is figure 1 and this figure 2 here. So what you do, most important thing is you go to here, you go to edit, you copy figure. That's all. Edit, copy figure. That's it. Edit, copy figure, go back to your Word file. Go down here, paste it here. All right, I'm going to go there, go here, paste it here. But obviously now you cannot see which one high quality, right? Never mind. We print as a PDF again. Print as a PDF, and then we compare. Let's stop, and we play document 2 lah. We create a PDF for document 2. I'm creating the PDF right now. Okay, this is the first figure that we did by using the JPEG insert. And let's go to the second curve here. And this is what we did using copy figure, edit copy figure, and paste. Let's look at it, how clear it is. This is how you do it. Super clear. And this is where journal paper, publisher, editor see your figure and say, "Ooh, high quality." So with that, I think I've done everything that I can to share my knowledge with you. Hopefully you can find it beneficial. All right. Okay, thank you.